and also for being there in time. I want to thank you for the job you are doing for the nation and for our brothers and sisters. My name is Charles Dominic Agwea, teacher at SAHEC at the Sacred Heart Chiterede Senior Secondary School in Chotera. We do this every day, every Wednesday, and then on Monday with the rest of the members for paper 3 and for paper 1 on those specific days. I want to start by maybe making a few comments before we can start on with today's session. Some of you who remember that I have always given work and I have always asked you to do the work during your free time and send it. I want to commend those students who have done the work and sent, I think 7 of you this time. But my observation is that some of you are like, I don't know whether because of the communication that was made by the president, some of you are pulling out slowly. But like I said, that one thing that can make us actually get there is to make sure that we do more of practice. It will be hard for you to master these concepts, to master the procedures, to master how to draw, if you don't do some work for yourself. So as we do high, let's keep our hands. And there are a few observations that I also wanted to make. I don't know whether you read some paper, I think could have been on Friday or something like that, where they were saying candidates will be doing exams in May. To me as a teacher and who has seen some history in this country, there is something that one can come with. Well, it is not yet official communication from UNEB, but those projections sometimes have something they communicate. I remember last year, similar incident of that kind happened. And I remember communicating to a number of students and tell them, let's make best use of the time. So the only way now for us to go is online teaching. Please, the few minutes you have, do your best. I said it last time and I still want to repeat it today. That one of the key things that can help you, please let's not complain. Let's not blame. Let's not do none of us knows and brought COVID. But today, as we live and as we do everything, we should be able to know that the little time we have, we use it well. Why? Because if we keep lamenting, if we keep complaining, if we keep saying this, we bring this issue, we shall not, at the end of the day, you as students will lose out in case they say exams are for you who have attended and done something, you will be at an advantage. So let's try to be serious. Let's do our best. And we perfect up on some of these areas. And like I said, the tactic of excelling in geography is passing the compulsory sections. Make sure you pass statistics with 23 and above. Make sure you pass field work with 23 and above. Make sure you also pass photograph and map work with 23 and above, so that you catch up. If things don't work out in the essays, you at least have some mark to start with, and that can make you be a better person. So the last time we looked at, I'm just giving a review, we looked at circular graphs, and I remember us taking through the procedures of construction, where we said that this is like a wall clock, a face-like graph, which represents information. This information can represent temperature, can represent rainfall, but it can also be superimposed with other economic activities, which economic activities can be activities that have happened within that particular year. They can ask you to draw independent of rainfall or independent of temperature alone, or they can ask you to draw both temperature, rainfall, and economic activities. So we went through all of these exercises and we tried. Some of you who did it, you remember. We gave the examples, so that was some of the work that we gave, and we also gave this one, those of you who remember. And then we introduced ourselves to the divided circles. And we said that the divided circles, in most cases, it's one of the methods that is being used today, or the commonest method. And some of you refer them to as pie charts. We looked at how do you calculate, where we said if we are going to do, you look at a formula of having the units given over the total that is given, multiply by 360. And I remember mentioning that the reason as to why we're using 360 is that all the pie charts, all the circular, simple divided circles add up to 360. That is why we multiply it by 360. We have other methods that we looked at, which can be in form of like divided. And I remember saying that when it comes to others which are divided, proportional divided circles, then it is you multiply by 180, which we also looked at. And I remember us going through quite a number of them and some of the things that we looked at. Sorry, excuse me. Okay, so we gave some exercise which some people tried to attempt. So we also looked at proportional divided circles. If you remember, we started on to them. Today we want to look at the proportional circles. The proportional divided semicircles is a half of the circle. That is why they are same proportional divided circles. But I remember explaining to you and also saying that one of the key things that you realize is that when it comes to us working out on these ones, you'll agree with me that I will give explanation like I have already said, but I may not. I want you first of all to understand what proportional divided circles are. So that you understand them, but at the end of the day, you can choose now to use. So what we are referring as proportional divided circles, they are actually circles which are like pie charts. The only difference with these ones is that they are not like the other. The others were half of it. So these ones add up to 108. These ones add up to 308. Unlike the others which were adding up 180. I hope I'm being clear. Proportion divided circles are circles that are constructed or that portray information, but into them, they are only particular circles, unlike the same circles that we're looking at. So this kind of method may be required to use information where you have many things you want to represent, maybe 4 or 5, but you want to use them in the different areas. The procedures for construction is almost the same. The only difference is that this one, we are going to use 360, other than the 180 that we were using last time. So in the wordings that I have put here, I've said that this, unlike the proportional divided semicircles, use full circles, but which are also proportional. When we say they are proportional, it means that they are living they live within the area, that they live within the units that are being given. They are to themselves is that it is almost equals. If you divided it, you'll find out that it is within. And we are saying that it mostly applies when totals are more than 2. You can be given totals and these totals are 2, and it's not like 1 like it used. And such that the proportional divided semicircles do not apply. All of the procedures followed in the above in the proportional divided semicircles also apply in this method. Except that in calculating the degrees, instead of us multiplying, we multiply by 360 rather than the 180 degrees that we're using in the same proportional divided circle. If you remember, the other time we were using 180. Why? Because they are halves, half circle. And therefore a full circle is 360. If you divide it, it is 180. That is why we're using 180. So instead of us multiplying by 180, this time we shall multiply by 360. I want to think you remember what we looked at. Another. Then we're saying that this method can be also used in conjunction with the map. For example, in a case of a map of an area where when it is provided alongside the data, various proportional divided circles can be drawn in particular positions. You can have these circles drawn in particular areas of the map that is given. Now, at this level, you realize that if in most cases, when they give you and they want you to draw this in the map, usually the map is given. But I don't want to say that it's a guarantee. At UNEB level, they can still ask you, or at national examinations, when it is UNEB paper, they can still ask you to draw the map. The map can be of East Africa, the map can be of Uganda, the map can be of any other country. However, what I should commend and what I should say is that when they ask you to draw the map, please don't give the concentration on drawing the map. What we only need is, for example, if they ask you to draw the map of Africa, just draw a sketch. So long as you are telling us that if they have told you to locate under South Africa, then you should be able to have South Africa somewhere. So don't concentrate and say, maybe I don't know where South Africa is. No, no, no. It is not a question. They may give you the data, draw, they want you to draw those divided circles and represent them on the map. If the map is not given and they ask you to draw, you draw it. But you should not be worried that you see, maybe I may not give. No, what we only want, can you be able to superimpose them? So, but you can draw them in absolute or single circles, or they can be superimposed on the map. So let's look at what we have. So that is what we look at. For example, we can be given an example like this one, data. And they are saying that the table below shows US's volume of domestic intercity flights and passenger traffic by type of transport. So you are going to find out that in this, they are first of all giving us the years that exists or that they got data from, but they are also giving us items, and the items are looking at the different types of transport. They are saying they are private cars, or they were private cars that existed in USA in 1950, in 1960, 1970, and 1977. The same, there was also domestic airways. There were also buses. There were also rail lines. There were also internal waterways. And here you find out that they have given us these figures. But down here, they have given the totals. That is why here they gave that it is information when it mostly applies when totals are more than 2. This is where we get this statement. And when we come here, that is why we have these totals. So we are going to use these totals. We are going to use this information to do our formulation as we did. You remember what we are saying. But if you have given and you want to turn this, then you will have to get the units divided by the total times 360. Now, in this case, we are expected. May I request Matayo, please, let's turn off our microphones. Let's try to mute them so that we are able to listen to one another. Okay, thank you. So I was saying that for this case, you are supposed to have these figures, and you use these figures to tabulate or to make the calculations for you to be able to get the degrees. So when we have got the degrees, then we shall use. So the method doesn't change, like we're doing with the rest. If those of you who are around, you remember what we say. This unit divided by the total times 360. You do all of this for 50, for 60, for 70, and for 1977. When we are through with everything, then at the end of the day, we are going to get the table of degrees. Now, my table of degrees, I told you that the table of degrees is important because when the examiner is marking the work, he will be able to look at that. So if we calculate, for example, these units over the 800, we are saying that, please, you will do this at your convenience. Like I said that, please don't, my worker may have mistakes, you never know. But what I wanted you to know, all for you to get, is that you'll have the table of degrees. After you have got that, if you converted this, you'll be able to get for 50, get this. For domestic ways, get 7.1. For buses, you'll get 18.4. For railway ways, you'll get 22.7. And then internal ways, you'll get 0.8. Please, I want to request you, if you have calculators, let's try to go through this. And then you will see. If you added all of these figures, you should be able to get 360. So after doing that, we have also done the calculation. We have got this total, this figure here, divided it by the total times the 360. And these are the units we have got Charles, for this one. Yes, please.
A quick announcement. I know some senior twos used to attend the lessons at this time. I think you are sharing they were sharing the room. Are there some form twos? I saw one writing. Form twos, if you are in here, please send a message to 772-592-826, and then we'll send you a link that you can use to join Form 2 classes. We are having some disruption this week, and we had last week, but we'll direct you to where we can have the lessons until we have sorted out the issue of links. So Form 2s, this is a class for A level at this time. Thank you. Kindly send a message I've sent in the chat room such that I can direct you. Thank you, Bwana Charles. You could continue.
Okay, thank you, Ayub. I think that is the information for, please, the senior twos. If you're on the platform, they have given you the number which you should send on, and you get the link so that you get to your place where you are supposed to have your lessons from. Okay, so I was trying to give you that the table of degrees is something that you draw when you have made the calculations. You get this over this, yet that is why we are getting this. Now, it should not be an assumption that in an examination you will get the table of degrees. No, I'm using this and I'm doing this because I'm teaching. So because it becomes hard, and then if I did all of this, so that when I come, you can check them over this.
Brother Charles, your audio is off. Brother Charles. Okay. So I think we've had the challenge with the Brother Charles's connection. Let me, in the meantime, show what he was showing, because he had sent his presentation quickly. Well, okay. Let me try showing what he was indicating earlier on. I'm looking for his presentation. I'm looking for Brother Charles's presentation so that I can project it quickly here. Where is it? Where is it? Let me project the entire thing. And maybe it could be here. Are you guys able to see? Brother Charles, are you back? Charles? Brother Charles, are you back? Okay. Now, I did, there was, let me mute. Kindly mute yourselves, people, so that you can be able to communicate. Now, Brother Charles was saying that with these proportional circles, that you need to draw the circles, and their radius is proportional to the size of the population that you have been given, or the totals. But when he gave the example, he showed us when the degrees are there. For example, here we see private cars. For 1950, it is 70. Please mute, guys, please mute yourselves. So looking at this one, the private cars, 704.7, domestic, 16.1, buses. So he has this information for the year 1950. And then we go to the year 1960 and so on and so forth. And the question that came up in the chat room is, where do these degrees come from? I think that is the question we'd like to tackle. Where do they come from? How do you get for 1950 from 704.1 for private cars to the degrees, which is 311.0? I'm checking the chat room to see whether you have been able to calculate that. Do we have someone who can guess how we arrive at the 311.0? If you do have, raise your hand, then I'll give you a chance to speak. Okay. How do we get these degrees? So Sylvia, unmute and then tell us how you think we progress to the degrees. Sylvia.
When we are dealing with the private cars for 1950.
Mr. Kalema.
Yes, sir. Brother Charles is back. I'm going to stop sharing. Could you, to get you on board, when we went off, we asked the students had a question. Where did you get the 311? So I posed the question to them, and one of them is answering how she got it. And then you'll pick up from there, sir. Okay. Please explain. Hello?
We get for 1950, we get that number which was the number which was given for private cars divided by the total times the 360 degrees.
Okay. So that's what you said, that you get the total for the year which of 1950, and then you also get the figure for the private cars. So you get the private cars figure divided by the total of the year times 360. Brother Charles, you're most welcome. Let us see.
So Mr. Goloba, he's off again. So FE
Is saying in the chat room, I'm seeing that you got 704.7 divided by 816. 816 is the total for 1950, then multiply by 360 degrees. I think when you do that, you get the 311. And then for domestic cars, for domestic airways, you get 16.1 divided by the total times 360. So you do it like that for 1950, you do it again for 1960, and then like that for each of the years until you have those degrees which has shared with us. So until you have the degrees which are shared. Okay, let's give it a minute and see if he gets back. Do you have another question at this time? As we wait for him, let me check in the chat room. Guys, yes. Okay.
Yes, Ayub.
Yes, sir.
Yeah, thank you for bearing me. My network is very poor,
Mm.
and I've kept trying, but I think things are not working out. But I think I can be able in case we are set and the students are all there.
Yeah, that's fine. We are able to hear you.
Hello.
Hello, Brother Charles. Are you able to
Okay,
hear?
thank you. Sorry for the students. Yeah, I'm able to hear you. I can hear you very well.
Great.
Can I go on?
Please go on.
Okay, thank you very much, Ayub, for helping me out. I ran short of my network was very poor, and where it's not stable. It keeps on off. But I'm happy that at least we have used our plan B. Now, for the students, I was explaining that you are supposed to draw the table of degrees. Now, the table of degrees helps and guides the examiner in knowing what exactly you are going to put. Because if you draw the circles or the proportional circles, in that case, you are supposed to use the table of degrees. The table of degrees also guide the examiner in knowing. So for the students who are asking, are you supposed to draw the table of degrees? Yes, because the table of degrees help, they are a guide onto whoever is going to mark your cars. In 1950, you have 311.0 degrees. And then for domestic airway, you have 7.1. And then for buses, you have 18.4, something like that. That is how basically you have to look at. So when you are through with the table of degrees, then of course, you now go on and draw the what? The proportional divided circles. Of course, after the tabulation, you have got like 311 for private, 7.1. When you total up those ones under 50, under here, under 1950, you will get a total of 360. The same even to 1960 and 1970 and 19. So it is those ones that you are now going to start drawing as segments. Maybe Ayub, we can move to the next thing. Hello. Now, when you look at those other, now this one is what we have drawn out of the other one. So we are now drawing circles which circles in this case are of the different years, but representing private cars, domestic airways, buses, and the rest of the thing. So you will find out that for 1950, we have we have 5 segments. One segment is representing private cars, another segment is representing domestic airways, another one is buses, another one is waterways, and another one is internal ways. The same will also be done to 1960, the same will be done to 1970, and the same will be done to 1977. Please remember that you are supposed to use the title, and the title is the proportional divided circles showing USA's volume of domestic intercity flights. Now, unlike for others, you are supposed to include the years, and the years you choose to put them onto the upper, because we may not know which circle or which divided the proportional circle is for what. So you put on top of it 1950, 1960, 1970, 1990, depending. And then you will also do that on the extreme end here. I've already put the what? I've put the key. The key I've named. For example, you see that blue is representing private, red is representing domestic. That color is like gray is representing buses, white is representing railway, and then the internal, the light blue is representing, is giving a representation for the internal. It is the one we are looking at in the first table. If you looked at it, that is ideally what you do have. So basically, that is how we go on. I'm seeing some. I don't know whether I should give some hands because I'm seeing some students raising.
I think
Okay.
so. I think it should be a good idea to hear from them. Okay.
It's okay. Let's.
Should I pick Charity?
Yeah, you can pick.
Charity, kindly unmute, and then we'll go to Darius. Charity first, then Darius. Charity. Okay, then Darius.
Thank you, sir, for that opportunity. Are you able to hear me?
Yes, we can hear you, Darius.
Okay. Sir, I was asking that, please, may you pardon about how we can get the actual values of these calculations?
Do you mean the values?
The actual values of this calculation, we said.
Yes, I'm hearing.
Yes, continue, sir.
Yes.
I was saying, did you attend the last lesson?
No, sir.
That is why now maybe the challenge. We said for you to get those values, you get the units. For example, the units for private 1950. Over the totals, which total is 60. When you do that, you should be able to get the representation of the degrees together.
Yes, sir.
That is how you get. So if you divide the 704.7 over 816 times 360, it should be able. So you do that, and you'll also do 16.1 over 1.6 times 360. You'll get the value. You also do for 41.8 over 816 times 360, and you do for the rest. You will also do for 1960, all of them. You do for 1970, all of them. You do for 1977, all of them. That is why you will be able to get the units we're getting.
Thank you, sir. I've picked the concept. Thank you.
Okay. Okay.
Brother Charles, there is another question. the one person, let me see who it has asked, how do I get the radius for the different circles that I am drawing? Because the radius seem to rest to show these sizes of totals probably. So how do I get the radius? I think that is the question. How do I get the radius? I think that is the question.
Teacher, are you hearing
Okay. To get the radius is that when we go to the units, Ayuba system, let me go back to example 1, where we are having
To this one.
Someone
Which one?
asked, how do we get the radius?
Yes, that is the question.
Yes. Now, go up a bit. No, up.
There?
Where we have example 1.
Yes, sir. This one, where you have the figures.
Where we have the table with, where we have the table, example 1.
Yes, I'm
No,
there now.
the upper one. Yes, there. Yes. Now, these figures are giving us a total of, for example, we have the totals. When you have 816, it is that one that is going to, that we are going to use to determine the radii or the radius. So you choose what you want appropriate. But me, I have chosen to use 1,000. So I get 816 over divided by 1,000 to be able to get the what? The radius. Why? I am breaking it into to be able to get the radius because there is no way I can draw the 8.1 as the total. But when I divide it by 1,000, for example, I will get 0.8. And if I'm able to get 0.8, then I should be able to represent that. I may get like 0.18. I will be able to represent it for 1950. Now, you also get 1,261. You divide it by 1,000. And you will also get maybe around 1.3. Then you get 1929.1, also divide it by 1,000, where you get like 1.9. Then you also get 2358.7 divided by 1,000, where you will get 2.3. So it is those units that you have got that you will now use to draw your circles, so that now those circles when you look at them, they are different in terms of the radius. It is those radius that you have got of 0. So you get your rule and get 1.8 and draw using a divider. You point and draw. Measure off again 1.3. You also draw. Measure off 1.9 centimeters and draw. And then 2.3 centimeters and you draw. Afterwards, you divide the segments according to the units you have got. So for the radius, you get the totals that have been given to you, divide by 1,000. I've chosen to divide by 1,000. It's not that you are supposed to use 1,000, but to me, it is much more manageable. On the principle, you remember the principle I told you that if we are going to draw, for example, a circle or a divided circle, it should not go more than 5 centimeters. If it goes more than 5 centimeters, it would mean that it would not be able to fit. But remember, these ones, we are now going to draw 4 of them. So that is why I'm looking at a manageable figure. That is why I have to divide it by the 1,000 so that it is able to fit within what we want. That is why I am choosing to use. You can decide to use, but when you are using it, you should not. For example, if you get all of them and divide them by 1,000, you should be able to get it. When you get the figure and you feel that the figure is too small, then it means you have to increase on the number so that you get something. Because if you get like 0.1, how will you represent that? It means now you have to get something that is. So me, I chose to use 10. To use 1,000. So you divide 1,000 by, you get 816 divided by 1,000. 1261 divided by 1,000. 1929.1 divided by 1,000. 2358.7 divided by 1,000. To be able to get the what? The radii, or the radius that you are going. Those radius that you get, or the radii you get, is supposed to be in centimeters. Now, for areas and purposes that you have got figures which are too big, You can still, it is you to play with the radius you want, I mean the units you want to divide with. It is you who determines. The examiner will not determine for you to. And when we use the totals, we don't use the percentages that we have calculated in the what? In the table of degrees or the table of degrees. That no, you don't use, you use the absolute value totals. That is the essence of that, for you to be able to have the manageable units that you are supposed to have down there. I want to think I have been able to explain.
Could you repeat that part where you say you use the figures? Could you repeat that part for them of the figures you use?
I am saying that when you are given, for example, like we saw the example one, which is having for 1950, 1960, 1970, and 1977. In these figures that they have given us, you'll ideally find out that, let's go up, Ayub, not this type of degrees. I want the absolute.
There.
Yes. Now, the reason as to why they have given us these totals, the totals are supposed to help us in determining the scale, which in this case is the radius. It is these ones, the totals that they have given us down here: 816, 1261, 198, I mean 1929.1, 2358.7. It is these ones that we use.
So
you get it divided by the unit.
So yes, it is these totals which we are using to calculate the radius.
Yes, please.
So the one which has small values, for example, 816 will have a smaller radius. The one which has a big value, for example, 2358 will have a bigger radius.
Yes.
Okay.
And that reflection will also be reflected on the type of proportional circles you are going to draw. That is why if it is small, it will also give a small circle. If it is big, it will also be a big circle. That is the proportionality.
We have a hand. Could we give her a chance, Ruth?
It's okay.
Teacher, you've said to get the radius, you get now like this total of 816. You get it and divide it by 1,000. And you get 0.816. Is that the radius or?
Okay. Brother Charles.
Yes, I have not had my network. Yes, please.
Let me repeat the question for you. Hello. Let me repeat the question. She's looking at how to calculate the radius.
I can hear you.
She has seen 816, 1261, 1929, like that. And you said that for you to come up with the radius, you divided 816 by 1,000. And you got 0.816. Is 0.816 the radius? Is that what you use as the radius? Thank you.
Yes, the values that you have got, if it is 0.82, it is the one you get, but that is what you use as radius, and it is supposed to be in centimeters. So you get your ruler and measure of 0.8 centimeters and use a compass to divide the circle. I mean, to draw the circle.
So,
I don't know whether I've been able to answer the question.
So it means that for the next one, which is 1261, the radius is 1.26. And then for the next one, the radius. Okay. Ruth, is your question answered? Are you comfortable?
Yes, I'm comfortable. But now, teacher, how about these things of pi r squared? How do they help?
The things of what?
Pi r squared, or they are not applicable here?
Okay.
You are Tumusime, you remember? Hello?
Hello, we are able to hear you. Brother Charles, continue.
Okay. In my last lesson, I remember explaining and I said that we may all be walking, going to Kampala, but among them, I have people moving on the legs, others are moving on in the vehicle, maybe others in boda. But I mentioned that examination time is part of the examination. And I said that I want to teach my students to understand. And I'm looking at students who are doing MEC. They have the aspect of mathematics and they are visiting other areas. But I also have students of history. Maybe I also have students. So what I look for is a quicker mechanism. The pi r squared is there, but it's a longer process to getting that. That is why I don't want us to go into it. Why? Because it is going to frustrate my students who may not be mathematicians. I get my point. But if you chose to use the pi r squared, it is also applicable. But I don't want to use it. Why? Because it's a long way to go. And I look for a shorter way to go to get. Because there is no mark that is given for the working of pi r squared. If we use that, what is important? And if you are able to give us that the radius with a unit, that is why you will put somewhere that maybe the scale for this is 1 centimeter representing 1,000, which will be okay with us. Are we together?
Okay, teacher, I'm fine now. Now, about the 1,000, the 1,000 that you divided with this figure.
Ruth, continue.
Do you just estimate it, or it's the one that I should use?
Ruth, which figure, Ruth?
Okay, these totals. I'm looking at this one of 816 divided by 1,000. Now I'm saying, did you just estimate the 1,000?
No, I told you that as a student, you are supposed to take a decision on what to use. And the decision is upon you. It is you to choose. You can decide to go with 1,000. You can decide to go with 10,000. But what I want you to have at the back of the mind is that when you are getting a figure, you must look for a figure which is convenient for you. What do I mean? A figure that will help you draw the circles and they fit. Assuming I divided that 816 by, let's say, 10,000. I would get 0.08, something like that. So does that favor me? At the end of the day, it may not be favoring me. If I also subjected that maybe to a bigger unit, like maybe 10,000 or 10, let's say I divide 816 by 10, it would mean I would get 8.1. I get my point. Now,
Yes.
if I get 8.1, it would mean that I'm going to get my ruler and measure off 8.1 and draw that circle. That circle will now be 16. I hope you understand. It will be 16 because if we say the radius, it means that is the middle part of it. If I drew it, it will be 16. Now, the question would be, will that circle be able to fit on the graph paper I have? The answer is no. That is why at the first time I told you that when you do these things, the first thinking I said that the graph paper that is given to you in the examination or in the UNEB examination is that on the horizontal axis, it has 16. On the vertical axis, it has 26. So if you are going to draw anything that is beyond that, it will not fit. That is why you will find out that the students sometimes will reach an examination because they have not planned. He will draw, he reaches somewhere and he say, master, give me another paper. Because he has already the website. But remember, that is already the time. What? Time gone. So those units, we get them in favor of us. You should look for something that breaks. That is why you can make those calculations quickly. And you say, so long as if we are going to deal with the circles, with the pie charts, with proportional divided circles and the rest, when you make those calculations, you must see that they don't go beyond 5 centimeters. If they go beyond 5 centimeters, it means that those graphs will not be able to turn. However, if the worst comes to the worst that you cannot, then you can change it into, instead of it being vertical, you draw it what? Horizontally. You change the graph paper. Instead of it being in the, how do they call it? You put it in the landscape instead of the portrait. I want to think you know the difference between the two. Portrait is putting it in the face, and then if you make it lie, it is the landscape. I hope I've been able to answer you.
Oh, thank you, teacher.
Yes,
Okay.
Brother Charles, there are quite a number of other questions. Would you want to take
Yes.
some or?
It's
because
okay, it's okay. Let me take, we can do little, but to the best.
Let me first read out the questions that were written to encourage people to write. Someone, Darius asked, is rounding off to the nearest allowed? For example, rounding off the first one, which was 0.8 centimeters, rounding it off to 1. Is it allowed?
It is okay. It is allowed under this.
Okay. Thank you. Now let's give Penelope an opportunity to ask. Penelope, please go on, unmute and then ask.
Yeah, thank you, teacher. And my question has been answered. I wanted to ask about rounding off.
Okay, so Penelope, your question has been answered. Thank you very much. Let's go to Marcelo. Okay. Marcelo?
Yes, excuse me, sir.
Yes,
Good afternoon, sir.
Good afternoon, Marcelo.
So what I was asking, the arrangement of the graphs. Do we just arrange them randomly or they should be in some pattern?
Okay. Brother Charles, have you been able to hear the question?
Yes, I've heard what the student. Now, the idea is that it is always good to do the descending or ascending in order, either from the highest to the lowest or the lowest to the highest. But if they are in years, for example, if they give 1950, 1960, 1970, 1977, maybe 1980, the idea would be that you give them in the ascending order, because the essence of us having such graphs is for comparison purposes. That if you look at 1950, you should be able to tell that there was an increase in maybe the flights or people using the car. So the arrangement is important, that you go the descending or ascending order. Either of them can work out. It is a question of you choosing to say, I will go the descending way or the ascending.
Okay.
Thank you. I thought you wanted to continue, Marcelo.
Teacher, it should be vertical, yeah? Yes, teacher, I was asking, should it be vertical or horizontal? Or it depends on the graph paper?
Oh, okay. I've now got the student. You are like saying when you are drawing the graphs, should it be vertical? If it is vertical, they will not fit. They may not fit, but
Oh,
if
so
you are
it
able
should
to
be
fit them,
horizontal, teacher.
it is okay. But the essence one would be that you do the landscape, because the landscape will help you to fit these ones.
Okay.
Thank you, teacher.
Did I see another hand, Marcelo? Okay, let's check the chat room. I'm checking the chat room. May you pardon me about rounding off. Do you say, supposing I rounded off to 1, and then where it was 1.2, I rounded off to 1. That is rounding off downwards. How far should we round off?
Okay, what I want to say is if we have a figure, we should round off to the nearest. That would be like 1 digit. It should not be a question of taking us that we are going to round off to the highest. That would be very hard. But the idea would be that you only round off 1. If, for example, if it is a 8.5 or something, then you round off to the nearest. When it comes even to, like, for example, some of these things, you will have challenges of small figures. That is why I said that sometimes you may be even forced to make it like only 1 centimeter, which is okay. So it's 1 unit. That's what we round off. It should not be more to ourselves that now I will round off to 1. No.
So, okay. So that does that mean rounding off to the 1 decimal place? So like 8.1 is not necessarily not 8.1372. What do you mean?
It would be like rounding off to the 1 decimal place. I don't know whether that is now the English we are talking about.
Okay, to 1 So guys, I think you got it. I think what is saying, the one which was 0.82, you don't round off to 1, because there was also 1.2. No more rounding off would be a bit difficult. So have 1 decimal place. I think that is what he's saying, 1 decimal place. Okay, and since they are centimeters, 1 decimal place is not a bad one. Do we have other hands raised? Let me check. Sir, are the circles supposed to be drawn only on the map? Evelyn is asking, are the circles supposed to be drawn only on a map, or do we have other cases where circles are not on the map? Thank you.
No, we have 2. Actually, the circles can be drawn in the way like these ones have been drawn, but they can also ask you to draw them on the map. And I think after this, that's what we are going to. They can ask you to draw the same map, the same circles, but maybe on a map, let's say, of Africa. Now, if it is on a map and they have given you a map of Africa, you will find maybe these, let's say, in different countries, let's say South Africa, Nigeria, and what. What you have to do is to attach these circles, these divided circles, within those particular countries. You at least realize, or you find out that a biggest share or a biggest part of it is within the what? Within that particular country that they have asked you to put in. But to answer her question is that they can be drawn independently as they are, but they can also be superimposed. What we refer as superimposed, they can be put on the map. And in such cases, we are looking at maybe location, but also at the same time, the units or maybe of people, depending on what all of the flights that I've shown in those particular areas. So it can be like this, but it can also be put in the map. So we shall look at them later on after I think this.
Thank you. There is another hand by iPhone. iPhone, you might want to rename yourself. You click your name or click participants on your phone. And then after that, you'll see your name. You click, you touch and hold it, then you'll be able to rename. But that will come later. Meanwhile, let me give you a chance to ask someone who has you've raised your hand and your phone is enabled iPhone. Please go ahead.
Thank you for the opportunity. So I wanted to ask, for us used to use the method of square roots, whereby I used to get the total If you get the total, then you square root it. When you square root it, you get the, like, for example, when you say the 300, sorry, let me, for example,
Can I share the screen and then you tell us what you're talking about?
Yeah.
That one?
For example, for us, we used to like add up the, like, for example, the private cars, we used to add up the 704 plus, we add up the old years, even in 2006, even 2060 plus the, sorry, 1960, 1970 plus 1977. If you get the total, then after you square root it, after square rooting it, you get the red bars. That's how we used to do it.
Penelope, that is a good, I mean, I don't know your name. That is a good way. But when you square root, you'll get figures like maybe 2, 3, what with some figure. Now that figure still remains high. At
Yeah,
the
it
end,
is. Yeah.
Okay.
End of it all, you are still asked to reduce it. For example, I want you to, if we had the time, I don't know how much time we had, we get now there. How do we get to a smaller? Hello?
Hello, please go on, continue.
Hello?
Brother Charles may continue. If you break, I'll repeat what you said. Continue, please.
Oh, okay. Okay, now what I was saying,
Continue, sir. It's all right. Okay, I think we have lost.
I was saying that, hello?
Hello, we had lost you temporarily.
My network is very poor for today, surely. But
yes, you're in Uganda, don't worry. But we will survive.
So
don't worry.
I was sure. I was explaining to the student that the process of getting that is also okay. However, it is a long process. Now, what happens is that the student will get the units. After getting the units, you will have many, which you can still not go and divide. At the end of the day, we still subject it, we multiply it by again another figure, which you must choose, which can be 10,000 or 1,000. Some information gives that you use the values that have been given. For example, if they say in thousands, you use 1,000. But like I said, examination time is part of the examination. There is no reason for a student to go through the wrong process. Because the 45 minutes they give you to answer a question is timely. So if you want to take the wronger one, the wronger process is okay, but it will lead you and it will take you to a lot of time. At the end of the day, if you do for example, what she was saying that you square root, it is okay, but after square rooting, you will still get a figure which is high, which figure will still be high, and you will need to manage it by again dividing it with some units, which is almost the same thing that takes us back. So there are no methodologies. There is no mark that we give, or that is given for those methodologies of going how we have calculated. It is not there. It is only to give you the units. So it is now up to the student to decide. That is why I told you that sometimes when I'm teaching students, there are students who have combinations which have arts related, others have sciences, maybe some are doing mathematics, and the rest. So under normal circumstances, find what is comfortable for you. But me, I want to choose something that cuts across and which is a quicker way. And it is not that they will mark you wrong because you have used this method. No. you will still get the figures, and we shall, and in most cases, you may even find we have all used the same unit. The other one has used the pi r squared, or someone has square rooted. I have used this one. We shall all get the same thing. You may even find you are getting the same radii or radius if you want it. Yes, there was some. Penelope, are you still having a question?
Yes, teacher. Okay,
Yes,
like this person of iPhone told us like if we are using the square root method, like we add up the private cars in different years. Is it really the way it is supposed to be done, or we add up the values in 1 year for different vehicles? Like I'm confused. Which totals do we use?
Okay.
No, don't be confused. That is why I did not want to use it.
Okay.
I did not want to use it. Why? It is something that takes, but ideally, if we are to use the square root, you get the values that have been given you, the total, and square root them. After getting the square root, or square rooting them means you get you put the figure of square root, you put 8, 1 fee as if it was the total. After what you get is those values, but you are supposed to get those values and again divide them by a convenient number you want.
Okay,
It's you who chooses that convenient number. That is why but that is how we go through them.
So a quick one for the person who said gets the totals for each of the individual sections for private cars, for airline, and then square roots them, where I think, brother, you are guiding that if you are to use that method of using the square root should be for the total, not for the individual component, for the individual parts.
No,
is that
will be high. It's not. Yes.
Thank
okay,
you for that
teacher,
guidance.
thank you.
And
but
then,
Ayub, I wanted to. Ayub.
Yes, sir.
I wanted, for purposes of guiding the students, please, sometimes I have talked to my students, even if I'm doing mathematics. You know, sometimes students have inclination. When one is doing mathematics, he feels better to use that method. Please, let's use the quickest method that can make us finish the work in time. Because at this level, one of the key things I have seen with A-level students do not fail to get or to excel because they don't know. But one of the greatest point, all students will always complain, time. Master, I knew everything, but time was not enough. So there is no one who is going to condemn you that you did not use the pi r squared or the square root. No, it is a question, am I able to arrive to what I want? If we are moving from here to Kampala, the questions of how I reached there may not be a question, but if we are going for money, they will not ask you that, now, how did you come? Did you use a boda? Did you foot? No, it's not that one. The question is, are we all there in time? That's the question. So I want to encourage students that please, let's look at mechanisms of getting what we want than sometimes complicating things for ourselves. And at the end of the day, you even reach somewhere and you get lost. Yet you have a quick way to go. Thank you. That's what I wanted to bring to the observation.
I think that is a great way of summarizing it. Okay, I'm about to move to the next slide, but Liu Harding really needs to mention her question or his question or comment. Liu, kindly move on, kindly tell us, what do you have?
Thank you, sir. I was asking, when calculating the radius, is it necessary to show the working?
I think the brother Charles.
Okay, what happens is that when you are doing some of that, you can do it anywhere, but it is not a question of that it is marked. We don't give a marker for that. For us, what we need is your representation down there, you will see them on the where we drew we have put R 1950 equals 0.8. What is important, and for us, what we want to look at is the radius you have calculated. So ideally, if I looked at a radius and I'm having 0.82, I will get the figures, the total, and divide by this, and I should be able to know that you have used the 1000. So if you do the calculation, fine, but it's not, there is no marker that is given for that.
Okay.
Thank you, sir.
But ideally, you need it because you cannot do otherwise.
Okay. Thank you. Stephen, Brother Charles, before we move on, I want to pick Stephen Odeke. Stephen, something is confusing to you. Could you mention what it is, Stephen? Right. You can, Stephen, unmute. I want to listen to what has confused you a bit. Then we. Your mic is now open, but we are not able to hear you, Stephen. Okay, so Stephen, we are unable to hear you. What you do, I propose you type your question in the chat room so that the facilitator can be able to respond to you. Brother Charles, what do you want me to show you next?
Let's move on to the next thing because we had looked at the proportional. Let me just go to those graphs you have shown because I want to explain down there something that I've been trying to talk about.
Okay. Fortunately or unfortunately, my computer is hanging up. So, yeah. But
yeah,
it is trying to open PowerPoint. I think I have an issue with the PowerPoint.
Okay.
And every time I load it gets a bit stuck. But if it fails, I'll load it again.
So I wanted to. I'm able to see. Let's move to the last to where we have the
table.
No, down.
There.
Yes, there.
Okay.
Now down there, I wanted the students to know if you look at the downer area there is somewhere like R 1950 equals 0.82 centimeters. I want to think you are seeing that. Then R 1962, it is extremely down. If you can zoom in your camera, you should be able to see. That is why I was saying that R means radius for 1950 is 0.82 centimeters. Then R 1960, meaning the radius for 1960 is is 1.3 centimeters, something like that. So that is where now I would know, like one student was asking, how do I know? When I see that, I will be able to know that if you have one mean that you have divided this with some unit like 1000. If you got a bigger value, let's say 2, and if you use the 2, it will be like maybe 1 point something or 0.8. So the bigger the figure, the smaller the unit of radius or the amount of unit of radius that you have. The smaller, the bigger the unit. If you divided it by, let's say 500, then let's say like 2 point something, maybe 2.1 or something like that. So it is one thing I wanted to emphasize so that you are able to see and also be able to follow. So if you are going to use that, that is what you are going to represent. And please remember to also represent these colors. You are seeing private because now those ones you can shade. You can use a shading to mean that that is for private, what. And please, you can use the other colors. It is not necessarily that you have only to use the blue and what. No, you can use the colors as you may wish, depending on what you have. So that is it, basically what we have to look at under that. Are you by request to go to another slide?
Okay. Thank you.
Excuse me, sir.
Yes, please. As I move to the next slide, please ask.
Teacher, so here, if we're round off our red eye, eh? Like on the first circle, you see we have 0.82, and then on the second circle, we have 1.3. So if I'm turned off the first circle, it means I'm going to have 1. And then if I'm turned off the second circle, I will also have 1. So check, as if it is not funny. No.
Penelope,
Yes, please.
I will request that you will go and make calculations for yourselves, and then you see. Already what I have here, it is possible that me I have already rounded off to 0.82. So go to the calculations and you will see. We have only said you can only take on only 1 decimal place. So first go and make your calculations. Don't too much based on mine. Why? Because I may have already rounded off to that. Now the rounding off is not 2 decimal places, because for you are like saying if you get 8.0, if I have 8.2, meaning I move that to 1 unit, 1 centimeter. No, it's not that way what we are saying. So you get the time after here. Take a screenshot. You go through that work by yourself. If you find out that you are having something, you are having a challenge, please inbox me. We can already share.
Okay, teacher.
Okay. And thank you. Brother Charles, Stephen was saying, yes, and he has written his comment, that what he was saying is that we should go on with the method that you have showed instead of using the square root, because the square root was a bit confusing. So he was mentioning that we go with the simple method that you have guided us with. So thank you, Stephen. Let's go to the next slide, which is talking about the advantages of the proportional samples. Thank you.
Okay, thank you. Now, like any other, these are common questions that are always asked, and me, I call them free marks for every student. Sometimes they say, give the advantages and disadvantages of using the method. We are saying that they are visually impressive, especially if they are colored well. What we are referring to, if you are able to shade, to give those shadings like that, you should be able to see that they give a visual, a good face look. It's an advantage. 2, the interpretation of these divided circles is easy, especially to those which are individually drawn, especially if they are not what? They are this for 1960, this for 1970, and even giving the colors that blue is almost for everywhere, knowing that these are the units. And you can also be able to know that I think this is the highest private, followed by maybe domestic and others. 3, we are saying that divided circles can be used on smaller space, and therefore they economize space. If we are to draw a population pyramid, I'm telling you, you will need the whole of that. A composite population pyramid, you will need the whole of that page. But here we have now used the 79, 4 years represented on one face or on one page that one would like to use. And also it gives a number of things that are portrayed. Then proportional and semi-pie charts can also be used alongside the map, especially when the idea of location needs to be shown. So when you have such information, you can easily tabulate it, you can easily superimpose it, you can have the same pie charts or the same divided circles, and these can be taken to a map to show. So you are using the map at the same time also using the what? they divided. So these ones may be showing the number of cars that were moving, but you are now putting them in the different locations. For example, maybe in a particular country or in a particular city. So you will be able to know that maybe if they are, let's say, give an example of Kampala and their districts, then you will say that I think this particular district, let's say Wakiso, has this. But it is also showing that within Wakiso, you are having people who are moving by car, maybe 50%, all 23 degrees. Others are like something like that. So in other words, it can easily be superimposed and it gives an advantage of others. Then the disadvantages, of course, like we have, there is nothing which is only advantageous. There are disadvantages. One, it involves a little bit of mathematical calculations. You see that people were asking us for us to take the pi r square. It may not be easily understood by every student, especially if you are more of the arts area. You may not know what to tabulate and what to put. But even if it is not that one, this formula of totals over, units over the total times 360, sometimes people may end up missing it. And even the alignment. So one must have attended to know what do you add and how do you add. That is why I said that you can even check yourself. If you make the degrees, those degrees must add up to 360. If they are not, if they are more, then there must be somewhere where we have messed up. So you can come out of, but the disadvantage is that it has the mathematical calculation. Therefore, sometimes it becomes confusing to some students, especially those who are not or don't have a background of mathematics or who are not good at that. Then comparing relative segments of circles without accurate measurement is always difficult. When you look at these ones, when you look at those segments that we are having, sometimes it becomes hard for you to know, is this surely 20%? If you look at those ones now, I want you to look at the blue. If you have not been told, for example, this blue one here, can you be able to know that this one is maybe 330 degrees? It becomes very hard. So at the end of the day, it may be confusing. There is a student who was asking, please, 1960 is not that it is like that. It is also having, I don't know what has happened to it. Maybe Ayubu touched it, I don't know, and the things disappeared. But it is also supposed to be having a segment. It's not that it's like that. It is also segment. It is divided. So
it rained along the words you are sending, so the information disappeared.
It got stuck. But it is also divided. Please, students, don't think that we have just made it like that. Then we are saying that proportional divided circles also require a lot of time to draw. These things require you to, first of all, do the tabulation. They require you to get a pencil, draw, get the radius or the radii. After that, draw one after the other. Then say them and then drawing. All of that is time. When you compare it to others, like to simple bar graph or to simple divided circles, they may not require a lot of time. You only draw one and it is done. So because of it being also taking a lot of time, it may also end up confusing and making the student feel uncomfortable. Unless if people have questions. If they don't have questions, let's move to the next slide.
They have.
I'm saying we have about.
They have questions. I think these are very interactive learners. They have questions, they have ideas, they have comments and thoughts.
Which is good. Which is good.
In the chat room, someone was saying, but now, what do I add? Do I add vertically or horizontally? For example, you remember someone who added the totals for private cars there. And someone is wondering, hey, which ones do I add? If I'm not given the totals, because in this case, the total for the respective years we are given. But if it was not there, how would I add? Can I add horizontally? Or do I always have to add vertically?
Okay. All vertically. Okay, now let's give the formula and how do I understand what to add and when to add. Let's go back to example 1. Now,
Yes,
when you look at this, usually when information is given, the information will give a unit. And what I'm referring to as a unit is private car, domestic airways, buses, yeah, those are units. Then in this form, they have given the different years. Now, you can only tell that when they give you a year, they will give you also another year and give another year. And these years will be mentioned. What the examiner will always want to know is that when they talk of private cars, they will give values for 1950, 1960, 1970, 1977. In the next, they will give for domestic and give also for these years. So it cannot be true that the examiner wants you to add these totals of the different years. Why? Because the representation is that for private cars, they are giving them in a sequence of the different years for 1950, 1960, 1970, 1977. So under normal circumstances, it does not become very easy for you to take a unit because this is one unit of private cars, but for the different years. Yet here they have told you that it is domestic intercity flights and passenger traffic by type, check, by type of transport. Now, the type of transport cannot only be private cars. It can be private car, it can be domestic airways, those are and the buses and the international ways. That is how it is. So ideally here, you would, even if they didn't have the total, this total would go, if you are to total up, you would total up going down. Why? Because we are looking at the different types of transport. Now, assuming it was not type of transport, let's say water usage. If that is the unit you are given. If they give you water usage and they say maybe water use by different companies or by different sectors, then they give you here, instead of private cars, they put agriculture. Another one, they put maybe hospitals. Another one, schools. Another one, something like that. Because of the aspect of them talking of that it is usage, water usage, it means water is used in the different sectors. So even if they don't give you the years here, and maybe these ones, they replace them by, let's say, different, maybe let's say department A, department B, department C, department maybe D. You would still tell that these are different departments that exist within that particular country. But the usages of water, the key sectors that they have given would be given on this side. So you will have to add them going down because it would mean that the water is used in the agriculture, but in that department A. The water is used by schools, but in the department A. The water is used by, let's say, mining area or mining sector, but in that department, up to down. So ideally, what you look at is you first have to look at that data and the information they are giving, that title where they are giving the type of the row shows what is very, very important for you to understand what exactly you will need and how you need to add. These things confuse students, and actually, you will also look when we reach into areas like divided rectangles, you will find out that the students, instead of doing things horizontally, they do them vertically. So, but we shall get there. But it is important for you to read and understand the heading, and the heading sometimes guides us on what will be coming. So, in this aspect, these are years that have been given to us, and these years you will find out that they are giving different units, but we have the sectors where people are moving from. So you have to go the vertical way, not the horizontal way.
Okay, thank you. So it means even for this particular question,
maybe Ayub, two.
Yes, sir.
Two, the other way that can also help you, if you did it vertically and you make calculations, it may not give you 360. Those figures will not be tabulating. That's why I told you that you can check yourself. If you want, you can do it. Try it. You do it. You do it. This one 7 0, and then you will find out that those figures you will have will not be tabulating. I told you that before UNEB gives an examination to students, one must have answered that question paper. Because when one is setting an examination, he must give the answers that will be used. If those answers are supposed to be improved, they can be improved, but he must give something that he has used. So that is why I'm saying that if you added them, for example, if you decided to go the vertical, the horizontal way, you will not get those units, and therefore they cannot add up to 360. They will be wrong at the end of the day.
Okay, thank you.
So those are the two ways you can know.
Okay. So Brother Charles, it means, according to your explanation, here where they put years, these could have easily have been, say, countries. So maybe 1950 could have been replaced by Uganda, another Kenya, another, etc., etc. So they could easily have been a different thing, not necessarily. Yes. Okay.
Yes. Yes, please.
Should I move to the next slide? Let me check the time, and we'll make a decision as to whether to move to the next slide. We have 12 minutes. What do you say, Brother Charles?
It's okay if the students don't have, we can do one, because I wanted just to relate them. You can also be given two. They can be given 2 years or 2 information of data, which they may want to have the superimpose this, the one that I wanted to do last. And I think we shall call it a day. Now, this is the example 2. You may also be given information which may be like that. We have looked at, now this is like example 2. The data in the table shows the racial composition of South Africa province in thousands in 1972. And a map provided. Use it to answer the question. So they can give you such data, and the data is having now total, and then the total also up. You see, there is Cape province, there is Natal, Free Orange State, and then now, if you look at them, you will find out that the totals which they are giving on the right-hand side is giving the totals as per the racial composition. But within the racial composition, they are giving the ratios of every individual province. Cape Town has, Natal has, Free Orange State has, and the Transvaal has. So these totals which are here, like 21 million, is a summation of the 4 to reach to that one. The same to the rest. So they can also give you this when actually in the real sense we need to have this. So that's why I have come up with the table of what? Of table of degrees where I have computed those ones. And I just want you to take a screenshot, work it out, and be able to draw for me one. That one is an exercise which I just wanted. However, I can show you an example of what that one can be like. So it means that sometimes when you look at these ones, they may be confusing, but it is one thing that one would want to know. Because if you get the 21628 then 176 13821, it should be able to give you the full total of all the people that are in Cape province. The upper one. So when you get these totals, the totals that are in the first column are the ones that are given for Cape province. Yes, please.
Okay, let us, now we slow. So we are saying, could you explain the total again here?
What we are saying,
this total,
we are having 2 types of totals. I want you to bracket up that total up. 672.
67 to this one.
The whole of that column there up to there.
This one.
The whole of that column there with the 1672 and then 42.
So the column for Cape
The whole
Province,
of that
this one,
upper one.
this one. Uh-huh.
And the other one also.
Wait a
Even for
minute.
Natal and the Transvaal.
Let me, okay. So you are saying I get these totals, right? This one. Is it what
Yeah, the
you're
one
saying?
is in the first, yes.
Okay.
Yes, that is what I'm saying. Now, those totals there is a summation of all of the 4 sects. For example, white, Bantu, colored, and Ascetics. It means that if you want to get the totals we are getting up there, we are getting the 1.113861 plus 3824175 plus 1762185 and 21. That is, if you add up all of those ones, they will make up to 6.7.
Okay.
If you also got these ones of 4, 4, 6, and they will add up to there. The same even here in the Free Orange State and also the Transvaal. Now, these other totals that are adding up, for example, the 1,1,1,386, and then 446, and then 29608, and then these ones now are the ones that are totaling up this side, which is giving us the 3.7.
So you are saying that for this second
However,
one,
such things can only be confusing if you have not understood what the question requires. If you read this, they are saying the table below shows the racial composition of South Africa. Hello?
Hello, yes, we are able to hear you.
Yes, that one represents the 3.7. And it is the same which also falls to these other ones in the 2.
Okay.
So what I'm trying to explain now, if you look at the question or what they are explaining, it is the taping of South Africa's people. This composition, racial composition, is South Africa had the apartheid, and you know that they have this ratio. Like maybe you are white, say these are Bantu, colored, essence. In Uganda, I would use like these are blacks, white, blue, something like that. That is the racial composition in a little kind of. But within those particular provinces, like Cape Province has white, blue, colored, and Asian. Natal also has it. Free Orange State also has it, and Transvaal. So this one should not confuse you. It is only you understanding what does the question want. The question is looking at racial composition in where? In South Africa. And if you look at the racial composition, is that they have given white. But the 3.751 is a total summation of all of the white people in Cape Province, in Natal, and in Orange Free State and Transvaal. So we want these ones to be reflected in the work we are going to draw. So I have gone ahead to draw like my table of degrees here, and I have already tried to reduce them. You already see that I have 1 here, and when I add up to this one, it is giving me 60. This one is giving me this. So it is these ones that I'm going to include. So that is why I was saying, do me the work. Please, in an examination, they don't give you this. This is my working out, all my workout, which I have done, but you can decide to use yours. Now, where are you going to get these? What are the totals and what am I going to divide now? That is where the students will get sometimes confused in this kind of situation. Are we together? So the totals that you need to, if you are going to draw up something, me, I've already indicated. So if you want to get, you will get the totals, because we now want to get a circle or a pie chart representing for Cape Province, but it is representing white, black, colored, and essence. We also want to get for Natal, also showing the same. Free Orange State, also showing the same. Translate fast. But now, unlike others, maybe we can go down a bit, Ayub.
Should I go to the next slide?
Ayub,
Yes, next, this slide.
can we go down a bit?
What do you mean? I go to the
Hello?
next?
Yes.
Okay, to the one which has a map.
Let's go to the next slide.
Okay.
Yes.
This
So
one?
you can be provided by a map. That map is now showing the different provinces, and you see Cape Town, Cape Province. Now this one is what I have drawn, and you will see that it is now showing the different, but they may give you when the map is just blank like the one that is up. So if you drew it, it will look like something like that. So you will find out that there is shading, but these circles are touching the particular what? Provinces. For example, it is here, it is in the Cape Town, the Cape Province. The other one is in the Transvaal. There is one in the Orange Free State and one in Natal. So what you will need is to, when you are drawing the circle, is you are drawing it vis-a-vis the white and the percentages, or the degrees. So you draw the degrees and shade them so that the shadings you put white, colored, Bantu, and Accentics, something of that kind. And then the title, and then the rest of the thing. So whether you are given the map or you are not given the map, they can still ask you to draw. And that's why I was saying that if they ask you to draw, it's not a question of you concentrating to say that, maybe let me draw the Cape Province passes here. No. The question in this is not about you drawing a beautiful and being exact to where Transvaal passes. It is a question of you giving an interpretation. For us, we shall know that, yes, this student knows that Cape Province is down somewhere, and he has got that circle or that divided circle. And
okay.
Yeah. So those ones are exercises which I wanted them to take. There was some more exercise, I think. If we slope it down, yeah.
I leave it at this.
Yeah, let them take a screenshot. That one is exercise for them to do, because usually I've always been giving them exercises. Some of them requested that we do. So if they are doing some, let them take that as their exercise to do, and then you can stop there. The next time, I think we shall look at proportional.
Okay, so thank you very much, Brother Charles. Could you take screenshots? We know that the mathematics lesson has started. We do have a geography lesson and then mathematics lesson. So those who are going for maths, this is the time, please run. The rest of us take the screenshot. I'm not stopping screen share because to allow you to take the screenshots. Brother Charles, do you have any closing remark? Because maybe we could now close.
Yeah, the closing remark I wanted to make, I want to encourage the students, please, let's stay strong. If there is any change or if there is anything that has happened that you have not been able to come to school, please don't lose hope. COVID will end and you will go back to school, but do your best. The little time you get, do. And then try as much as possible to try to see that you do something to, at least on a daily basis, so that there is something you grasp. The day they open up, you will be better off than any other person who has not been attending. Please don't mind about the money. Education is an investment. And therefore, because it's an investment, the little money you are spending, don't take it as much, even if you spend 20,000 shillings. Are you aware at this moment that some of you have been paying 800,000 shillings as your school fees? and you are now paying maybe 50,000, let's say for data, don't take it as a big thing. Please do yourself, invest. In Luganda, they say, "Mweteke musente." Invest in yourself so that at the end of the day, you are able to do your best. Thank you, Ayub. And I want to wish them a good day and a good week.
Okay, thank you, Brother Charles. To everyone, thank you for today's lesson. Brother Charles, we really appreciate. On Friday, we will have paper 1 with Mr. Asea. Please, we are changing the time slightly. He might begin slightly earlier than 2:30, so be there in time. If it doesn't begin at exactly 2, we'll wait for him a bit, but he might come in early. Ruth, I see that you raised your hand. Ruth, please make your comment.
Teacher, I would like to get Mr. Charles' number so that I send my work after doing it.
Okay. So, Teacher Charles, kindly share your number.
My number is 0772
yeah. 54
91
yes. 91
08.
08. Thank you, teacher.
Welcome.
Thank you. And Brother Charles, I think we'll be able to upload some work on our platforms. We'll summarize and upload for easy follow-up. Otherwise, the rest of you, thank you very much. Have a good day. Keep safe, social distance, and protect your family. Keep praying, keep working hard, keep being the best.
Thank you.
Nice day. Bye.
Okay. Bye.